Okay, so a while ago, we did this demonstration where we took a coil of wire and we passed a really big electric current through it, turning it into a temporary magnet. And so right now, it's just a coil of wire. It doesn't do anything. When I turn on the current and pass current through there, I get like a really cool, groovy magnetic field. And I can extend that magnetic field by putting like a piece of iron in there. Let's get that paper clip out real quick. And so by passing a current through a coil of wire, I can create a magnetic field. So today's hypothesis is basically the reverse of that. What if I took something that was already a magnet, like this dude right here, and passed it through the coil of wire? Could I generate a current by using a magnet, basically the reverse of creating a magnet with a current? So what I'm going to do is I'm going to replace the battery eliminator box here with this device, which is a galvanometer, basically a very sensitive ammeter. So I'm just going to plug these in right there. Kind of get that squared up there for y'all. And so what this is, get a little bit closer here. So again, this is a galvanometer. It's basically a very sensitive ammeter. So you'll notice here the reading on it is microamperes, and it reads current in both directions. So if current's going one way, it flicks to the right. If current's going the other way, the needle will flick to the left. And so if we take our magnet, there's our magnet, pass it into the coil. Oh, cool, we get current. But now the current is stopped. Let's see. Oh, we got more current. Let's try that again. Push it in. Whoa. Okay, I had current there for a little bit. Let's get my my nail here. Okay, so if I slowly push it in, notice I get a small current. If I quickly pull it out, notice I get a big current, but in the opposite direction. So the thing we need to notice here is that a still magnet doesn't do anything, but a moving magnet creates a current. And the direction of the current depends on which way the magnet is moving. Also notice, there's those bells again, man. Also notice that when I pull it slowly, I get a small current, and when I move it quickly, I get a large current. So basically, what this is an electric generator. I can make an electric current by moving a magnet in and out of a magnetic field. If you're like me and you lost power last week, having something like this would have really been handy. The problem is that you have to have a lot of magnets and a lot of motion because these are still really, really, really tiny currents. Microampere is not a very large unit of current. But this is the basis of a device you might call an electric generator. So if you got a bunch of these, and you get really strong these, and you can move them really fast, then you can generate lots of current. So let's get into the physics of learning how that happens, why it happens, and how do we describe it.